Live stream is starting soon. It's starting soon. It's about to start. It's about to go down. Live stream is about to go down. In fact, it's probably already going down. Oh, there I am. Hello world, it's Siraj. Good to see you guys. ML Squad is in the building. Let me shout out some names. Igor, Lordius, Patchy, Mick, Raj, Sudanshu, Brennan. Yo, we got the whole machine learning squad in the house right now. Who is ready to learn some TensorFlow? I'm so excited to learn some TensorFlow. Masood, Gaurav, Spencer. All right. Okay, cool. Hi, everybody. Hi. Okay, so let's get down to business, as they say in Mulan. Let's get down to business and defeat the loss function. Okay, so anyway, let's start off with a 5-minute Q&A. So hit me up with your most intense machine learning questions, or you just want to know, anything. We'll go for it. And then we're going to use TensorFlow to classify housing prices. Okay, it's going to be dope. It's going to be the first time we're using TensorFlow from scratch in a live session. It's going to be awesome. Okay, so here we go. Hi. Let's begin. I'm doing good. I'm so down. I do have a sore throat, but I'm a human. I know, but it's crazy. But it's cool. What kind of method approach do you use to manage your time? Mick, great question. What do I use to manage my time? I write down what I'm going to do for the whole week before the week starts. So every Sunday I'll write down, the weekly goals. I have a weekly to do, I have a daily to do, I have a monthly to do, I have a yearly to do, and then I have a 5-year to do. So I plan things out in intervals like that, and I make sure my goals are accomplishable goals, so that I get that positive feedback, so I can keep going. Is Google release his own OS? Chrome OS, yes. R language, no R, only Python. Recommended books on computer science or cryptography. Cryptography is so dope. I wish I could just deep dive into cryptography. That is like some ancient Egyptian pharaoh mummy. You know what I'm saying? Like you have to. A good book on cryptography is my book, Decentralized Applications, the best-selling software engineering book on Amazon for 2016. And a good book for machine learning is Machine Learning: A Probabilistic Approach by I forgot the name, but that's the name of it. What do you think of Star Wars? I love Star Wars. I'm actually not I love the old ones, the new ones. I was kind of disappointed by Episode 7, so it's whatever. It's kind of conservative bet for Disney's part. We have to make our own stories, guys. We are a new generation. We're going to make our own stories, and they're going to be as good, if not better, than Star Wars. And we're going to have machine learning. It's going to be dope. And when we make stories, it's going to be technically accurate. What if there are more than one local minima in gradient descent algo? Great question. So so sometimes we have more than, so with gradient descent, it's like a 3D graph with a valley, right? We want to remember what I talked about last live stream. We want to drop a ball into a bowl and see where it fits. But what if we have multiple valleys? Well, then that's when a second order optimization function comes in. We have to find the local minima that is closest to going to best optimize our function. We're going to talk about that later, but the key word to remember is a second order optimization function. Tensor calculus, that's exactly what we're going to do, Sion. Not at a low level, but at a high level, because TensorFlow is going to do a little bit of magic for us. Can you explain maths behind TensorFlow? I will absolutely explain the math behind TensorFlow. TensorFlow is better than Torch, exactly. Hey, Siraj, are more layers always better in a neural network? Great question, Kumar. No. Not always. Usually it is, but so if you have a smaller data set, you don't really need that many layers. So remember, with machine learning, there's always a trade-off. And in engineering in general, and in life, there's a trade-off as well. But we want to, when we optimize for so when we increase the layers, we increase the computational complexity, but we also increase the accuracy. So there's a trade-off. How should I prepare for Google Brain residency program interview? Kaggle challenges are great, and the TensorFlow intro docs. Watch all my videos, but you probably already have. If you do all that and you apply the code, you'll be good to go. Decentralized, yeah, that's the book name. Can you give new research idea that can implement in TensorFlow? Yeah. So here's an idea I've had for a while. Somebody should roll with this. take the synthetic gradients paper from DeepMind, synthetic gradients. So they kind of like stopped using backpropagation just for this paper. And then take the idea of one-shot learning, so probabilistic programming, and then combine these two ideas together. So synthetic gradients and one-shot learning. Boom, there's your landmark paper for the year. I don't have time to do it, so someone just roll with that. Is TensorFlow usable in Raspberry Pi? Yeah, actually, somebody made a wrapper for Arduino. So 2 more questions, and then we're gonna get started. How does genetic algorithm fit into machine learning? Genetic algorithms are good for optimizing hyperparameters for us. And let me talk about that for a second. So I've got some emails from people who are like, and also articles where people are like, what do you think about this? Where Google are using machine learning. Google's using machine learning to optimize machine learning. So like, what do we do? Guys, machine learning is not going to take your jobs away, okay? We will be, so even if there's a job apocalypse, machine learning engineers will be the last people to have jobs. Not that that's going to happen. We're going to create new jobs in the new data economy, and we're going to have basic income and things like that. Hopefully from cryptocurrency. So check out my post-social coin. It's already possible, and also Grant coin. But don't worry about machine learning replacing your job as a machine learning engineer. If that actually happens, then we solve intelligence, and then the idea of jobs and money and scarcity all goes away anyway. Okay, so let's go ahead and start. Let's go ahead and get started. Best way to start deep learning is to start my course, which is this course. Okay, so what? Okay, so that's the 5-minute Q&A. Here's what we're gonna do. We're gonna use TensorFlow to classify housing prices. Okay, so that's what we're gonna do, and I'm gonna use a Jupyter notebook for once. So let me go ahead and start screen sharing immediately, and we'll get right on into this ish. Here we go. Okay, so let me move this chat window over here so I can still see you guys. I don't need to see myself though, I just need to see you guys. And then I'll also have QuickTime up, just so I can, see myself. All right, new movie recording. All right, and then that goes away. And I'm right here. Okay. Let me just minimize myself. Yeah, the webcam's kind of blurred. I'm gonna get a better one. Okay, so here's what we're gonna do, guys. Okay, so we have a housing data set. One-shot learning was the other thing. Okay, synthetic gradients and one-shot learning. Okay, someone do that. And just in general, one-shot learning. So we need more one-shot learning progress, because not everybody has huge data sets and huge computing power. Okay, so I'm going to explain things slowly this time, okay? I'm going to, thanks Alexander, much love. Okay, so I'm going to explain things slowly this time, okay? So I want to start off by talking about a neural network, okay? So a lot, okay? We see this image a lot of a neural network, right? But the one thing I want to say is, you see all these circles, we call them neurons. They're not actually objects. They're not classes. These are just representations of numbers. Let me zoom in a little bit. They just represent numbers, okay? Because when we input data into a neural network, in TensorFlow, we call it a computation graph. And these are not actually like neurons. These are not class objects. When we take an input, let's say like, what we're gonna do, housing prices, and we apply some matrix math to it, it's going to take that value and it's going to do, so if it's a 1 value and when we multiply by a matrix of say 3 values, it's going to then become 3 or 4 values. Those values are what we represent as neurons. They're not actually objects. And then we take those values and apply a set of matrix operations to them, and then boom, it's the next set of neurons. But these neurons are not actually classes. They are values, okay? So that I just want to start off with that. So that's that. Now let me show you guys the graph. Let me show you guys the data first. So here's the data set. Let me zoom in on this. Okay, so this is a set of housing prices. Okay, so the first one is the index, which is the number. The next one is the area, which is the size of the house. The next one is the number of bathrooms. Then the price, and then the price per square. The price per square inch. Okay, so that's what that is. what we want to do is we want to classify this, but this isn't a we don't have labels right now. We're going to add labels, okay? We're going to add labels where it's going to be where it's going to be either a good buy or a bad buy. Because what we want to do is, given one of these features, okay, we're going to decide which features to use, but given one of these features, we want to then classify the house as either a good buy or a bad buy, okay? So let me shut down my screen for a second, just so the bit rate goes up a little bit, okay? I want it to be not that laggy, okay? So that's what we're going to do, okay? So that's our data. So let's go ahead and start doing this in a Jupyter notebook, okay? So I'm going to do it in a Jupyter notebook. All right, so the first thing I want to do is talk a little bit about, let me just make sure that this works first. Let's see. Okay, it works, great. Okay, so TensorFlow, why are we using TensorFlow in the first place? So yes, this stream is going to be, let me make the font bigger. Actually, the font is, let me see, okay. We're going to use TensorFlow because Google created it for, this is going to be a supervised problem, okay? Yeah, it's price per square foot. This is a supervised problem. We're using TensorFlow because in TensorFlow, TensorFlow was created by Google and it was built to scale. They've used it for many years. They released it. It was kind of like, you know, Zeus coming down from Olympus and giving fire to the humans, right? We know that TensorFlow can scale. We know that it's reliable because it's used in production by Google. I mean, Google search uses TensorFlow, okay? So this is a reliable library. Although PyTorch is pretty cool too. It just came out this month and it introduces the concept of dynamic computation graphs. Usually we have two interpreters, right? We have a Python interpreter and then we have a computation graph interpreter. But what PyTorch does is it has one interpreter for everything. Okay, so and so Jupyter Notebook is really is a great concept. Basically, it allows us to view our code and add markdown to our code. It lets us add a bunch of pretty things to our code. Yes, Prometheus is the right answer that I was looking for. Okay, so let's go ahead and start by importing our dependencies. Okay, so we want to classify our problem. And also, let me show you guys what our neural net looks like. I didn't show you guys what this is going to look like. So this is what it's going to look like. Okay, so we're going to feed in two inputs, and we're going to apply a set of weights and biases, use a softmax function, and then output the housing price as well as the label, which is good or bad. Okay, so we'll talk about that in a second. Let's go ahead and first import our dependencies. All right. So yes, I'm focused on the content. Thank you, Palash. So here we go. Import pandas as PD. Why? Pandas is our beautiful library to work with data as tables. Work with data as tables. That's our first library. Okay. So the next one is NumPy. NumPy is going to help us use numbers. Use number matrices. Both pandas and TensorFlow need it. So use number matrices. Okay. The next thing is matplotlib, because we're gonna show this graph. We're gonna show this graph in a second. And what else? We want matplotlib's pyplot as PLT. I prefer TensorFlow, pyplot to Keras, and finally, TensorFlow as TF. Okay, that's it. Those are our four libraries, and we can go ahead and compile it. Boom. So because there are no errors, we can keep going, right? So that's a great thing about Jupyter/IPython notebooks is that they let you compile as you go, so you can see what is happening. Okay, so that's what we did there. Now we're going to load the data. Now, so step one is to load data. Load data. Okay, so let's go ahead and load data. How are we going to load data? Well, we are going to use the pandas library to help us do that. So the first thing we're going to do is we're going to use the pandas read CSV function. So because we have a CSV file, okay. So we're going to read this in as a DataFrame object. So what is a DataFrame object? A DataFrame object is an object in memory that pandas creates from a CSV file that we can then easily parse. And I'm going to show you what I mean by easily parse. So we're going to take this DataFrame variable that we just created, and we're going to list what we're going to remove the columns we don't care about. So how do we know which columns we don't care about, right? So let's go back to our data for a second. We have several columns here. Which are the ones that we want to use to predict if a house is good or bad? Well, what we're going to do is we're going to take out the index, because that's not going to really give us anything. It's just a numbering of what each column is. The next one is let's say area and bathrooms, right? So those are the two features that we're going to use, area and bathrooms. We're not going to use the price or the square. We're not going to use the price or the square price, because when I look for a house, I want to make sure that I have a certain, and that's just what I'm using, right? Deciding which features to use is its own, it's its own discipline in and of itself. What features should we use? And a good rule of thumb to go by is what features would you personally use to make a prediction? Okay. Yeah. Let me give you guys this data. How do I give you guys this data? Oh, I can create a gist. So in a gist, I'll say, let's just take all this. Let me give you guys this data real quick, and then I'll paste it into the chat so you guys have to say it. So data.csv, and we'll create a public gist. Boom, and I'll paste it in the chat. Ready? Get ready for this, guys. I'm gonna paste it in. Boom. There's your data. That's a data file. All right. So now you guys can do that along with me. All right. So we are going to remove the features we don't care about. Okay. We're going to remove the features we don't care about. We don't care about the price. We're not going to care about the square price. We only will care about the number of bathrooms, and what was the second thing? The area. That's what we're going to be using right now. Okay. So, and axis is 1 because we're only going to use the first axis from the data set. All right, so DataFrame.drop. So we removed. So let me say what we just did here. We removed the features we don't care about. All right, so we remove the features we don't care about. Now we're going to only use the first 10 rows of the data set in this example. So we only want to use the first 10 of these, right up to here, okay? No Oxford, I don't want to define that. Okay, so how do we say that? Well, easily enough, the great thing about a DataFrame object is we can say I want from row 0 to row 10. Boom. So that's going to tell us that we want to only use the first 10 rows. That's it, okay? So that's it. So now we have our DataFrame object. So let's go ahead and print this. And here's the great thing about Python notebooks is we can now print this and see what we have. And it'll give us an error if it doesn't work. Okay, so there we go, invalid syntax. So let's see what I did here. So on this line, DataFrame.drop, it's pointing to this axis equals 1. And the problem here is invalid syntax. So we have index, square price. Oh, yes. So okay. So this bracket actually goes here. That's where the bracket goes. Now let's compile. Okay. So there we go. There is our beautiful, clean, formatted data, and we're only using the first 10 columns, and we're just using the area and bathrooms as our features. And remember, feature selection is an entire discipline in and of itself. And we could have used the square price, and we could have used the price as features, but what I'm looking for are the area and bathrooms, okay? That's what I look for when I try to predict if a house is a good buy or not for me, okay? So now we have our features, so let's introduce our labels. So what we just did, so step 1 was to load the data, and step 2 is going to be to introduce labels. Because right now there are no labels. So we could just do regression, right? Because we could then predict the next value. And what do we use regression for? For predicting the next value in a continuous set. So that's what we do for that. But what we're going to do is we're going to convert this into a classification problem. So add labels. So that's our step 2. So we're going to take that DataFrame object. And if anybody doesn't have the data, go ahead and ask, and then someone's going to paste it into the chat, the link to that gist. All right, so what we're going to do is we're to introduce the labels. So we want to say our labels are going to be either a good buy or a bad buy. And so how do we represent that? Well, for simplicity's sake, let's just use binary numbers, right? So a good buy is a 1 and a bad buy is a 0. So let's just randomly add like, you know, a set of for our 10 values. So we have to count 10, right? So we want 1, 1, 1, 0, and then, you know, we'll add some variety in there. So let's see how many that is. That's 3, 6, 9. But we want, we have 1, 1, 0, 0, 1, and then 0, and then 1. Okay, so yeah, that's 10 values. So we're going to add our labels. And so so 1 is good and 0 is bad. So 1 is good buy, and 0 is bad buy. Okay, so 1 is good buy, 0 is bad buy. Now, now you can't see the first part of the code. So let me repaste the link. I'm going to repaste the link. Boom. Okay. You can't paste the link. Okay, so now you can't see the first part of the code. Well, let me go up. I can't go back. We have to keep going. Okay, so 1 is a good buy and 0 is a bad buy. So we've defined our set of labels. Now the next step is to turn true false values into 1s and 0s. So we're going to say the location variable is going to define those labels for us. All right, so let's go ahead and add the y2 values, which will, hold on a second. So y2, and we're going to use a DataFrame object where it's y1, 0. Okay, so what did we just do? So what we just did is we said y2 is a negation of y1, right? So we define y2 as a negation, as y2 is a negation of y1. It's the opposite, okay? Right, so there's that. Axis 1 is the column, okay? So now, y2 means we don't like a house. Y2 means we don't like a house, okay? So let's go ahead and define y2, okay, DataFrame.block, location, and we're saying, okay, so what is that value that we want? Y2, and then we'll say, okay, so we're going to convert it to an int value, right? So we want to remember that the type we're converting to is an int. So how do we convert it to an int value? So we're going to say as type int. And so what this says is it says turn true false values into 1s or 0s. So turn true false values to 1s and 0s. Okay, and now we've done that, and so now let's print out what we have here. Let's see what this looks like. Great thing about IPython notebooks, we can just print what we have here. We definitely have a syntax error, so there it is. And I think Sagar mentioned this earlier. So we are going to add to line 3, so which one is that? Our bracket, yes, just like that. Okay, and so now we have an extra one. Okay, so what did we do? So we added labels, but instead of saying good or bad, we added 2 labels. So this is just for, you know, simplicity's sake. We don't want to convert text to integers. We're just going to say a raw value. So if y1 has a value, that means that is a good buy. And every time y1 has a value, every time y1 is 1, y2 will be 0. And every time y2 is 1, y1 will be 0. Okay, so that's just our way of labeling our data for now. Okay, so we've added our labels. That was step 2, remember? So step 1 was to load the data, which we did, into a DataFrame object. We parsed it. And then step 2 was to add the labels to the data, right? Which makes this a classification problem, because we're going to classify this data. Okay? We're going to classify housing. If a house is a good buy or a bad buy based on the area and the number of bathrooms. Okay? Not bedrooms, right? Well, I guess, I mean, the data didn't have bedrooms, did it? Okay, so, but yeah, bedrooms would probably, you know, be better if we had that. So now we have all our data in a data frame. We have to shape it in matrices to feed into Tensorflow. So now step 3 is to prepare data for Tensorflow. So depending on which machine learning library we're using, we can we will prepare it a certain way. But in general, no matter what data we have, we're going to convert it into tensors. So let me explain what tensors are. So so tensors are it's a high level. So tensors, and so tensors are generic version of vectors and matrices. So a vector is a vector is a list of numbers. Then vector is, let me just write this out. This is important because we see these words a lot. It's a list of numbers. Then a matrix is a list of numbers. Okay, so a vector would be a 1D tensor. A matrix would be a 2D tensor. And then whatever a list of numbers is would be a 3D tensor, and then that just continues. Okay, so a tensor is like a very generic term for both matrices and vectors. And these tensors are how we represent data in TensorFlow, right? And guys, machine learning neural networks, it's all just matrix math. It's a collection of operations that we apply to some input matrix, and we continually apply them like a chain of these operations until we get to an output. And then we apply an optimization function to minimize a loss. And I'm going to talk about that in a second. We're going to do that, but that's what this is. Okay, so that was a little short thing on tensors for a second. But to get back to what we're doing, so we're going to take our data frame, and we're going to say, let's see, we want to take the area and the bathroom. So we're going to take our features, right? We're going to take our features and we're going to convert them into tensors. We're going to convert our features into tensors. So convert features to input tensor. That's what we're going to convert our features into an input tensor. And this session will be 50 minutes or probably an hour. We'll see. As matrix, and we want to say, okay, so as a matrix, that's going to convert. So now we're going to convert our labels to input tensor as well, right? So let me show you guys this image again. Okay. All right. So here are our, see this like right here, these two purple circles, those are our input tensors, our features and our labels. So we're going to feed that into a site. We haven't created our weights yet. So if you just block out everything but these two purple lines, these two purple circles, that's what we just created, okay? So now, so that's what we did for that. So now we're going to convert our labels into features. Okay, so I'm sorry, our labels into tensors. So we'll say DataFrame.loc. Syntax error is probably going to happen. So we'll say, okay, so dot location, and then what were those labels that we created? And guys, we could easily have one label as well. I'm just, it's okay. So I gotta focus on this. Let's see if this compiles. Okay, so syntax error. What do we have here? So right, so there's an extra bracket. All right, so area bathrooms. We have location. Okay, so this needs to, we need an extra bracket here. And then what else do I have here? So for Y1, I have a bracket. Oh, I need another bracket, and then we'll compile that. Let's see what else we got here. Oh, a comma. Aren't Jupyter Notebooks so great, guys? We can just continue. We can just compile as we go. We can just compile as we go. DataFrame.location, Y1, Y2. What's the dealio? Okay, we're going to remove that. We want to say what is going on here. We've got Y1, Y2, dot, location, and this is a bracket. Boom. Let's see. Oh, okay, let's see what's going on here. Whoa, that's a lot. None of area bathrooms are in the columns. Hold on a second. Area bathroom are in the columns. Let's see what we did here. So we said DataFrame.location. We converted area bathrooms to as a matrix. And then we said, okay, as a matrix. Interesting. Okay, so right, but so we did have area bathrooms. Remove the closing brackets. Remove the closing brackets on. Remove this one, and we want to add. Interesting. Missing quotes. Oh, there it is. Right, missing quotes. That's what it was. Oh my God. Okay. Yes. All right. There we go. Okay, good. That scared me for a second. Let's print out what we had here. So what did we just create? Boom. So what is this? This is what our input matrix looks like. Okay. So we have the area and the bathrooms, and this is what our labels matrix looks like. Let's print out our label matrix. Okay. So that's our input matrix and that's our label matrix. Guys, we have our inputs. Now we're going to prepare our parameters. And so what step are we on now? We're on step 4. So step 3 was to prepare the data for Tensorflow. So we formatted our data for Tensorflow. And now we're going to step 4 is to write out our hyperparameters. Okay, so what are our hyperparameters? So the first one is going to be our learning rate. And so when did we last use our learning rate? We used the learning rate when we, in last live session, to sum that up, the learning rate controls the rate at which we learn. I know that's kind of, so what's a better explanation? The learning rate defines how fast we reach convergence, to be technical. Convergence is when our model is at its optimal fit, when we have that optimal fit where the error is minimized. And the learning rate defines how fast we get to convergence. We can't just say, oh, make the learning rate 1,000,000 and just get there as fast as possible. Because if you go too high, then your model's not going to converge. But if you go too low, it's going to be too slow. So remember, like all things, it is a trade-off. That is the word of the day. Machine learning is a series of trade-offs. And dope as F trade-offs as well. Okay, so the next thing is the training epoch. We're going to train this thing 2,000 times. And why 2,000? I don't know. I mean, we could try 10,000 in a second. I don't know. You know what I'm saying? So, and that's what we do. We train for a number of epochs. We see our results, and then we say, well, is this prediction accurate or not? And then if not, then we'll tune our hyperparameters in a set again. Okay, so then the number of display steps. So how often do we want to display? So then how often do we want to display the process of training? And then the number of samples, which is going to be the size of the number of labels, which is 10. Okay, so that was those were our hyperparameters. And now, guys, we are ready to compile and make sure that runs. Is to create our computation graph. So a bit on computation, create our computation graph / neural network. Okay, so computation graph, neural network, they're the same thing. But before we get to that, let me do one quick review of what we've done so far. We imported our dependencies. Then we loaded our data, which is a CSV file. The data contained a bunch of features, but we only wanted to use the area and the bathrooms as our features. We removed everything else. Using those two things, we want to predict if a housing price is good or not. But guess what? There are no labels in our data. So what did we do? We added labels because DataFrame objects are really easy to parse, add data from, remove data from. And so we added labels. Y1 is when Y1 has a value 1, it means it's a good buy. When Y2 has a good value, that is when it's not a good buy. Then we prepared our data for TensorFlow. How do we do that? We looked at our DataFrame object and we converted our features into an input tensor. And then we converted our labels into an input tensor as well. We printed them out, we defined our hyperparameters, and now we're going to write out our computation graph, okay? So let's go ahead and write out our computation graph. So let's go ahead and do this. So the first thing I'm gonna do is I'm gonna create a placeholder for our feature input tensor that we just defined, input x. And what this is doing is, so for our feature input tensor. So in TensorFlow, we'll feed it in an array of examples. Each example will be an array of 2 float values, area, number of bathrooms. And so none means any number of examples. You know, we could define, which is, you know, usually the batch size, but we're just going to say none, so it's just generic. We can say however many we want. We'll allocate it. We've allocated that number beforehand, and this allows us to have any number of examples. And 32 because that's the size of this input tensor. Okay, so oh sorry, not 32, 2. That my mistake. So 2 because we have 2 features. Okay, and it's a 2D matrix, right? Because we have 2 features. So we've done that, and so the next step is to now create our weights. So create weights. And so another thing, placeholder objects are gateways. So placeholders in TensorFlow are gateways for data. It's how we feed data into our computation graph. Our gateways for data into our computation graph. All right, so the next step is to create weights. So how are we going to create our weights? So we're going to define our weights as W. And we're going to say tf.variable. And so let me just write this out. So we'll define our weights, and it's going to start off as a set of 0 because we haven't, and that's how you should start off your weights. For a simple example like this, although with transfer learning, you know, your weights aren't 0; they've been trained beforehand. So this is a 2x2 float matrix, 2x2 float matrix, and we're going to keep updating them. That will keep updating through the training process. That's what we're going to do. And why do we use a variable? Well, in TensorFlow, a variable is variables hold and update parameters. So variables in TF hold and update parameters. And be that weights, or any other things you want to. So they're basically in-memory buffers containing tensors. Okay, to be a little more technical about it, but these are our weights. Okay, so the next step is to add our biases. So we're going to add our biases. So add biases, and so we want 2 biases, right? Because we have 2 inputs. We want 2 biases because we have 2 inputs, and this is also going to be a TF variable. Okay, so, and this is a 2x2 float matrix. Okay, I already typed that out. And we're going to close the bracket here and add a closing parentheses. Okay, so let's see what this, actually we're going to do more. So let me show you guys what we have so far. So now what we've done is we've created our input tensor. Let me actually use this little square thing. And we've created our weights. And now we're going to add our biases. So this is what we're about to do. So we're going to add these other purple square-looking dots. So yes, we're going to use backpropagation to update our weights in a second. But first, we have to define our biases. And why do we use biases? Well, biases are going to help our model fit better. So a good example is example is B in the y equals mx plus b equation. B is the bias, like that. So, right, so because B takes that line and it adds the y-intercept, which makes it fit better. So that's what biases do. They're a part of the larger goal. It's like, you know, if you didn't have B in the y equals mx plus b, the line wouldn't be the right line that you're looking for, right? So, okay. And I'll go over, you know, everything we've done at the end, guys. So right now we've added our biases, and so the next step is to calculate. We're going to perform some matrix math. So now we're going to multiply our weights by our inputs. So this is our first calculation that's happening here, right? Because weights are weights are how we govern how data flows in our computation. Weights are how we govern how data flows in our computation graph. Okay, so let's go ahead and perform this. So we'll define this as y values, and we'll say, and yes, weights we can initialize weights as random as well, and depending on, you know, what you're doing, it can be different. But right now we're initializing them as zeros. And to perform this actual matrix multiplication step, TensorFlow has this great built-in matrix multiplication function that we can say, okay, so take our inputs and then our weights and then our biases, and what are we going to do here? We're going to calculate the prediction to do that, we're going to multiply the input matrix by the weight matrix and then add the biases. So let me write that out. Multiply inputs by weights and add biases. Okay? So it's kind of like y equals mx plus b. It's just similar set of operations. Okay, so we've done that, and now we're going to do our softmax function, okay, which is our sigmoid. Softmax is another word for sigmoid. So we've done this part, right? And now we're going to do this part, which is we're going to take those values and we're going to apply a softmax to it. And what does softmax do? Does anyone remember? Shout it out in the comments. I'm going to explain it in a second. I'm going to type it out. If someone can shout that out, I will give you a shout out if you can tell me what the softmax function does. So we're going to say softmax. Apply softmax to this value that we've created, right? We're going to apply our softmax to this value. Apply softmax to value we just created. Okay. So and then what does it's an activation function. So is our activation function, and it does something. Oh shoot. Okay. Hold on. Okay. So let me go ahead and. So yes, it normalizes our value. So what softmax does is it normalizes our value. And what do I mean by that? It takes our value and it converts it to a probability that we can then feed to our output. So it's our last step before we feed to our output. So let me make sure that I've typed all this ish out perfectly. Okay, so on line 14, tf variable does zeros. I said tf variable does zeros. Oh, I need a bracket here. Okay. tf.zeros. Be laser focused on what I've done here. So let's see. Interesting. So there is an extra value here. Let's see what's going down here. tf.variable, tf.zeros. Oh, extra dot. Okay. Okay, so now the next step is to say, oh, it's good. You know what it is. It's all good. Okay, so I need to add a bracket there, I think, right? Yeah, so I'm adding one there, and I want to add one here, and then we're going to say compile. And so then for the y values, it's telling me what I've done wrong. So it's saying, hey, Suraj, listen, buddy. Listen, you need to apply your matrix multiply x, w, b, tf.add. Okay. What else we got here? Y values. And let's see, name x is not defined. X is not defined. What do you mean x? Oh, because I didn't define it, yes. So x is that value, okay? Great, great. So, and I hit enter. So I need to go ahead and add one more thing for training. So, okay, so what did we just do? We added, the code is gonna go online, yes, I'm gonna post it in the comments when I'm done. We've got 15 minutes. Okay, so what we're gonna do is we're gonna say, we've got that softmax value and now we can feed it to our output. So let me type that out. Okay, so what are we doing here? We're going to feed, oh, so we never did this part. So we're going to say feed in a matrix of labels. So let me just go over what I've just done here. Okay, so these are our two placeholders, right? So x is up here and then y is down here. But this, right, so one is our labels and then one is our set of features. We created our weights, and then our biases, and then this is our computation step right here. We multiplied our weights by our inputs, and then we added our biases, and then we used that value that we calculated, and we input it into a softmax layer, which converted it into a set of probabilities. Okay? So there's that. And now we're going to perform our training step, perform training. So we've done these steps, and now step 6 is to perform training. Step 6 is to perform training. All right, so let's go ahead and, so this is the magic part of TensorFlow. So if you were here in the live session last week, then we did this manually. So let me just write out what we're about to do. What we're going to do is we're going to create our cost function. And the cost function we're going to be using is the mean squared error. All right, so we did this last live session. One of the great things about a course is that we have continuity. And so we can say minus y. So this is going to be the equation. And I'm going to show the equation in a second. But what this does is it says we want to calculate the error. So between our two y values, and we're going to divide by the number of, so the mean squared error is going to take the average of the difference in values, which is our error, the squared difference, and that's what this is doing. So reduce sum basically computes the sum of elements across the dimensions of tensor. So let me write that out. Reduce sum computes elements, the sum of elements across dimensions of a tensor. And so then let me show the equation for this in a second, what we just did. And so the two different values we're using are the two different values we're using are the predicted values and then the actual values for the outputs. That is our cost function. We want to minimize this cost function over time. And to do that, we're going to perform gradient descent. So the great thing about TensorFlow is we can just define gradient descent as our optimization function. We don't have to actually write out every step. And in gradient descent, every step means we're computing the partial derivative with respect to our input variables, which in our case would be the set of weights and the biases. So that's it. We can just say we have a cost function. We want to minimize that cost using gradient descent, and our learning rate will define how fast we want to do that. Okay. So do not call me during a live session. Okay. So let's see what we've got here. We're going to say y is here, right? And right, so this should be y underscore. So that's why that didn't work. And so the next thing is we want to make sure that name y is not defined. How about now? No, it is defined because I just updated it. There we go. Great. So yes, so I updated the y. And now we're going to create our session. Okay, so let's initialize our session. This is still a part of the training step. We're going to initialize our variables and TensorFlow session. So in TensorFlow, we encapsulate our computation graph. We encapsulate our computation graph using initialize all variables, using a session object. So in TensorFlow, whenever you want to do any kind of training, you have to first initialize all the variables. And what initialize all variables does, it does exactly what it says. It initializes every variable that you've declared beforehand. That means those tf.variables we declared beforehand and the placeholder objects we did beforehand, right? So every TensorFlow generic variable that we defined beforehand, this initializes it for the session. So I mean, this could be, this could be done under the hood as well. But for now, and TensorFlow asks us to define it manually. So we created our session, and then we run it by using all the variables that we've initialized as our input. Okay. And of course, there's an error. So no attribute initial all variable. So what was that? So initialize all variables with a set of parentheses, and then tf.session. Let's see what else we got here. tf.initialize. I misspelled initialize. Okay. Initialize. Great. Okay, so here we go. Let's do this. This is the last bit that we're going to do. This is the actual training loop. This is the training loop. Okay, so let's go ahead and do this. So for every epoch that we have, for training epochs. How many people do we have in this live session? 300 people. Go. Awesome. Okay, so for every training epoch, we define as 300. What was it? What was the number? 2,000. We define as 2,000. We're going to run our session given our optimizer, which is gradient descent. So this is where we're performing gradient descent. And we're going to feed in. This is where we actually feed in those placeholders that we defined earlier. So those placeholders are going to be that. The first is going to be that x value, which is going to be our features, the input x. And the next one is going to be for the labels, which is going to be our input y vector. Okay, so there's that, and so that's it. And so now that's it, really. And now we can just write out our debugging message, which is going to be write out logs of training. So if I display step equals 0, and then we'll say, let's run this session, given our cost function, given our, and then we're going to, and we actually already just did this, but we're doing this just to print it out, just so we can see, what's happening at each step. Okay, so our input is going to be that first tensor, and then our other input is going to be the other tensor that we defined. Yep. So then print training step is going to be actually, so this part I'm just gonna paste this part right here because we don't actually. It's just logs. That's it really. So what we're doing is we're printing out the training step, and let me just go ahead and run this now. Okay, so our first syntax error is going to be x. Right, this doesn't need that. Thank you. What else we got here? X, input x, y. Feedict equals session.run feedict equals. Yo, okay, yes, okay, awesome. So boom, so that's how fast it trained because it was only 10 values. Okay, it was only 10 values. And so what is happening here? Let's look at this. The first column is our set of training steps, right? And the next one is our cost function. And the cost function is minimized over time, okay? And then eventually it's finished training. So what is so it ends up with the cost function of 0.109, whatever, right? So is this good or bad? I don't really know, but it's better than the first cost value, that's for sure. We don't know if it's a good cost function or not because we kind of arbitrarily defined what those labels were ourselves. So let's go ahead and test this out. And how are we going to test it? I have a cough / sore throat, and I'm also like really sick, which is like I don't have time for that, guys. I'm teaching this dope ass course. Okay, so we're going to feed in our input, and we're going to test it out. We're going to see what happens now. Okay, so this is our output. So what is it here? So this is the prediction, right? So we've trained our model, and now we're going to do our prediction, right? And so it's guessing that they're all good houses because these values are all above. So remember I said we have y1 and y0. So it's saying let me go back up for a second so you guys can see what I'm talking about here. So we defined, remember this y1 and y2? That's what it's outputting, guys. That's what it's outputting. It's just the y1 and the y2. And it's saying these values rounded are closest to 1, right, on the left side. So that means it's all 1. And the values on the right are all closest to 0, which means it's 0. So what it's saying is it's saying all houses are a good buy. But that's not the case. So it's got 7 out of 10 correct. But the actual thing is they weren't all good. They were just some of them were good, right? So only some of them were good. So 7 out of 10 correct, which is not bad. How to improve? Maybe we could add a hidden layer. Add a hidden layer. Add a hidden layer. That's what I would do. I would add a hidden layer, and then I would try it again. So that's a kind of, so that's my example for this. Okay, so let's go back to screen sharing. Okay. Stop screen sharing. Go back to me. Hi. Okay, so that's what we did for that, and I'm going to add the code to the GitHub link. 5-minute ending Q&A, and then we're good to go. And I have a video for you guys coming out on Friday, which I'm super excited about. Hit me up with your questions. Let's go. Anything. Why are you using Jupyter? Any special perks? Jupyter because it allows you to compile and see what you're doing in real time. It's great for visually looking at, especially for data. It's great for visually looking at what you're doing. Exactly what Jake said. How do you choose the number of hidden layers or not of unites while trying to develop a neural network? It depends on how big your data is. The more data you have, generally, the more hidden layers. The more data you have, the better it is to add more hidden layers. Right? PyTorch versus TensorFlow for newcomer. Absolutely TensorFlow. Don't even trip. Well, but PyTorch has some great architectural ideas that I think we can, we'll see where that goes. It's a really exciting space, guys. It's only January, and we're already seeing so much innovation in this field. In fact, this pace of innovation is accelerating itself. It's insane. How many layers should we add? For this case, I just answered that. Can you say something about Google's DeepMind machine learning? Well, I mean, they haven't really done anything this year yet, but just wait. Give them like 2 weeks. I expect to see some state of the art in something paper in within 2 weeks. How to classify an image data set. We're going to do that in 2 episodes for this course. But high level, you want to label data set, a supervised approach with labels. Look at Google's Inception. You don't even have to train it yourself. They've already trained it on 1 million images, and you can use transfer learning to apply that, and then add in whatever other images you want to classify. And because of transfer learning, you don't need that big a data set to train it. And I have a video on that called Build a TensorFlow Image Classifier in 5 minutes. How much coffee did you have? I had a cup. Is it the same live session, the one you were doing with Udacity? Yes. Any videos on recurrent neural nets planned? Yes, it's coming out in 3 days. Do you think the Udacity deep learning course prepared me for a deep learning job? Yes. What advantage? If you do the assignments, okay, there's a caveat. You have to do the assignments. You can't just watch the videos. You have to do it. Do it. Like Shia LaBeouf. Do it! I'm a huge Shia LaBeouf fan, by the way, guys, recently. Because he does art for the sake of art. Did you age? I'm 25. Did you study at university? Yes. What? Computer science, specifically robotics. Anything on memory networks? Yo, I want to do memory networks. That's some advanced shit. That's like generative adversarial networks. Shit that I find super interesting at the bleeding edge of the field, but we've got to get our basics down. If you should take something out of this live session, what you should take out are 3 things. 1, how to do gradient descent and backpropagation. 2, an idea of what the main variables are with TensorFlow. That means placeholders, TF variables, the optimizer function, weights, and biases. Okay, because everything's going to build off of that. If you get those simple things, then everything else is going to be much, much easier. And then the third thing is a softmax function. Activation functions. An activation function is what we use to convert numbers to probabilities. There's several types of activation functions. In this case, we use softmax. Which university? Columbia University. But guys, I want to end this with 1 piece of advice, and then we're good to go. A lot of what we learn is what we tell ourselves we are capable of doing. That's what degrees are. Degrees tell us, they allow us to tell ourselves, hey, I now know this, I can do it. But we have to flip that way of thinking. It's not about, oh, I have a degree, now I'm a computer scientist. Oh, I have a degree, now I can do X. No, if you study something and you do it, if you create the code and it compiles and it runs and it gets the output that you wanted, you now have the ability to do that. So don't be restricted by the dogma of, oh, I need to read this or I need to do this before I get to this. Think of something you want to build, start building, and along the way, learn what you need to build it. By the end, you are going to get really good. Because if you've ever engineered anything before, then you know that if anybody asks you a problem about it, you will know every answer. Why? Because you had to deep dive into it to be able to build that. Okay? So that's it. All right, so believe in yourselves, basically. Believe in yourselves. The world needs you guys, okay? We need you. We are starting a revolution, okay? We are in the midst of a revolution, unlike anything the world has ever seen before. And we are going to do some awesome shit, okay? We're gonna do some awesome shit, okay? That's it. Okay, so thanks guys for watching. The video is coming out on Friday. It's gonna be dope. And continue the conversation in our Slack channel. For now, I'm going to do the math tutorial in a second. Okay, so anyways, for now, I've got to work with Udacity on something. I want to go down to Udacity and just hang with them and see what we can do. There's some really cool people. For now, that's what I got to do. So thanks for watching. Love you guys.